Sometimes when we calculate limit of f of x as x goes to a, we get 0 over 0 and it's called indeterminate form. So when we have indeterminate form, how we can evaluate the limit? We have in this video we check 4 different strategies. Let's see number 1. If we have rational function like limit of, okay, let me write the name. We use factoring strategy. If we have rational function, if we have polynomial in numerator and denominator. So this is the example. As x goes to 3, so let's evaluate the limit is minus 2 times 3 minus 3 over 3 minus 3 is equal to 0 over 0, and as you see is indeterminate form. So if we have indeterminate form, we use factoring strategy. If we have polynomial function in numerator and denominator, what I'm looking for is x minus 3 is the common factor I'm looking for in both numerator and denominator. Let's factor this rational function. So is x minus is equal to x minus 3 times x plus 1 over x minus 3 as x goes to 3. As you see, we have common factor here. The common factor we were looking for is x minus 3, and I have it now. I can cancel. So answer is limit of x plus 1 as x goes to positive 3. So it's 3 plus 1 equals 4. Let's see example number 2. If you have any limit that involves absolute value function, how we can solve this kind of limits? For absolute value limits, is good to write your absolute value function as a piecewise function. Let's see the example. Limit of absolute value of x minus 2 over x minus 2 as x goes to 2. Okay, let's write this limit as a piecewise function. Let me write limit first. So limit of x goes to 2. So you can write it in absolute value form. How we can write it as absolute value form? Just you can say x minus 2 over x minus 2 if x is more than 2, and negative x minus 2 bracket x minus 2 over x minus 2 if x is less than 2. But how we can calculate this limit? We can calculate left and right side limit. So second rule is left hand side limit because it's less than 2, and first rule gives us right hand side limit because it's x more than 2. Okay, let's calculate limit from right side. Is x minus 2 over x minus 2 as x goes to 2 from right side, so is equal to 1. And limit of this function from left is bracket x negative bracket x minus 2 over x minus 2. So you can cancel x minus 2 by x minus 2. And as you know, this is left hand side limit because it's less than 2. So is equal to minus 1. As you see, left and right are not equal. 1 is not equal to minus 1. Then you say limit of absolute value of x minus 2 over x minus 2 as x goes to 2 does not exist. Why? Because left hand side and right hand side limit are not equal. Sometimes we have rational exponent. In this case, we use substitution. strategy, and in some textbook is called change variable. Let's see the example. Limit of x to the power of 1 over 6 minus 1, x to the power of 1 over 3 minus 1 as x goes to 1. As you see, we have a rational exponent. How we can make it easier, how we can solve this question? You just change variable. 1 over 6 is less than 1 over 3. So x to the power of 1 over 6, let's say x to the power of 1 over 6 is t. Then x to the power of 1 over 3 is t squared, right? Because x to the power of 1 over 3 is 1 over 6. X to the power of 1 over 6 to the power of 2. That's why is equal to t squared. Okay, let's rewrite this fraction. This limit is the limit of t minus 1 over t squared minus 1. Because x goes to 1, so t also goes to 1, because t is equal to x to the power of 1 over 6. So t goes to 1 equals limit of t minus 1 over t minus 1 times t plus 1 as t goes to 1. As you see, common factor I was looking for is here now. T minus 1, t minus 1, you can cancel the common factor, equals limit of 1 over t plus 1 as t goes to 1 equals 1 over 1 plus 1 equals 1 over 2. Let's see next example, example 4. Sometimes we have radical in given fraction or given function. So how we can find the limit in this case? Because again we have indeterminate form, we need to use rationalizing strategy. Let's see how we can use rationalizing strategy. For example, if we have limit of root x plus 1 minus 1 over x as x goes to 0. Okay, let's sub 0 in this fraction. It will be 0 plus 1 minus 1 over 0 equals 1 over 1 over 0 equals 0 over 0. As you see, again we have indeterminate form. In this case, we need to multiply the fraction by conjugate of numerator, because problem is here, radical is here, and conjugate of numerator is root x plus 1 plus 1, because here is minus, conjugate is plus, always is opposite sign. If it was plus, you could write minus, but in this case, because it's minus, opposite is plus. Okay, let's copy paste the same expression here. Okay, and then is equal to, as you see, is a minus b times a plus b, so we use difference of squares, equals limit of root x plus 1 squared minus 1 squared over, you copy paste denominator, so is x plus 1 minus plus 1 as x goes to 0 equals, you can cancel a square by a square root, equals limit of x plus 1 minus 1 over x times root x plus 1 plus 1 as x goes to 0. You can cancel 1 by negative 1, so equals limit of x, just let me change the color, you cancel 1 by 1, you only have x, so is x over x times root x plus 1 plus 1 as x goes to 0. You can cancel x by x now, equals limit of 1 over root x plus 1 plus 1 as x goes to 0. Now you can sub 0 in this fraction, equals 1 over root 0 plus 1 plus 1 equals 1 over root 1 plus 1 equals 1 over 2. So answer is 1 over 2. Okay, now is your turn. I want to give you one example. Please find the answer, and just you can write your answer as a comment. I will check your answer. I will give you feedback and explain the answer. Limit of root x plus 1 minus square root of 2x plus 1 over square root of 3x plus 4 minus, let me just see the question, sorry about that, minus square root of give me a sec. Two x plus 4 as x goes to 0. Please find the answer. Thank you so much for watching this video. See you later. Bye.